Okay, so welcome to this video, and in this video we are going to talk about binary numbers. Okay, now as part of your binary numbers, as part of your IGCSE computer science course, you are supposed to be able to convert from binary to decimal and decimal to binary. Okay, so I'm just going to show you a couple of techniques that you can use to convert from binary to decimal and decimal to binary. Okay, so the first thing to remember is some important facts about binary. Okay, so binary is base 2. That means it's made up of two symbols. Okay, and those two symbols are 0 and 1. Okay, and that means it goes up in powers of 2. Okay, so those are the four things that you need to remember about binary numbers. Okay, base 2, that means it has two symbols. Those two symbols are 0 and 1, and that means that we go up in powers of 2. Okay, so let's just revise our powers of 2. Okay, so the way to do this, and you want to do this in your exam too. Okay, so we do 2 to the 0, we draw a table like this. Okay, I'm going to run out of room, we'll just see how far I can go. So we'll go 2 to the 0, we'll do 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. Okay, so 2 to the 0. Well, anything, hopefully you should remember this from maths. You do this at IGCSE maths. Anything to the power of 0 is 1. So that one's 1. 2 to the power of 1 is, of course, 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. And then 2 to the power of 5 is 32. Okay, so there are powers of 2. And what you should try and do in your exam is you should try and remember those. I'm going to rewrite those again, actually. You should try and remember those all the way up to 8 bits. So that would be 1, 2, 4, 8, 16, 32, 64, 128. Okay, so in the exam, my recommendation is that if you get a binary number question, you draw this table. Okay. All right, so let's go from binary to decimal first. All right, so let's come up with a binary number. All right, let's say, all right, so there's a binary number, and all I've done to convert it is I've just started on the left-hand side, okay, and I've written in the ones and zeros that make up that number. Okay, now all I'm going to do is I'm going to add all the ones together. So I've got 128 times 1 plus 32 times 1, okay, plus 16 times 1 plus 4 times 1 plus 2 times 1. Okay, so I add all those together. We can get rid of all those times 1s, can't we? Okay, so I can just add all those together. So we got 128 plus 32 is 160, plus 16 is 176, plus 4 is 180, plus 2 is 182. Okay, so this number in binary is 182. Okay, so hopefully that's a pretty simple mechanism just to convert a binary number into its decimal equivalent. Okay, so there's its decimal equivalent, and there's our binary number. Okay, now we can do it the other way around. So imagine in the exam that you're given a decimal number. So let's come up with a decimal number. Let's say we give the number 45. Okay, so what we need to do is, all we do to work out what 45 is in binary is we say, well, do we need 128? No, we don't. So we put a 0 there. Okay, do we need 64? No, we don't. Okay, do we need 32? Yes, we do need a 32. Okay, so we can do a little sum on the side here. This is, again, what I'd recommend you do in the exam. So we've got 45 minus 32. Okay, so we're left with 13. Okay, so we've got 13 to make now. So do we need a 16 to make 13? No, of course we don't. Okay, do we need an 8 to make 13? Yes, we do. Okay, so we can subtract 8 from this, which gives us 5. Okay, do we need a 4 to make 5? Yes, we do. Okay, subtract 4 from 5, we get 1 left. Do we need a 2 then? No, we don't. And then we're left with a 1, and we need a 1. Okay, so 45 in binary, in 8-bit binary. So this is specifically in 8-bit binary. Okay, so 45 in 8-bit binary would be 0, 0, 1, 0, 1, 1, 0, 1. Okay, so that was a quick video just to remind you how to convert binary numbers into decimal and decimal numbers into binary. I hope you found this useful. Thank you for watching.